Good morning, student. Now, today we discuss the last topic of this lesson. Conservation of momentum. You know what is momentum? The product of mass and velocity is known as momentum. Suppose there are two objects, A and B. Object A, its mass is ma. Object B, its mass is mb. Now, u for momentum or velocity ua, right? Velocity of object A, velocity of object B, u for initial velocity, right? So, initial velocity of object A and initial velocity of object B. Now, after the conservation of the momentum, means both the bodies are meet together, then the force is extracted by object A on B is known as FAB. F means force from A to B, and the same force but in opposite magnitude, you know that according to the Newton's third law, then is by object B to A, means FBA. So FAB and FBA are equal in magnitude but opposite in direction. So FAB equal to minus FBA, right? Force equal to, according to the Newton's second law, right? M final minus initial, V means final velocity of object A, right? And is equal to FBA. So B mass final minus initial upon T. This is A acceleration for second. This is acceleration for first object A. This is for B. Now T cancel. This minus comes to right left side, it becomes plus. So minus MB VB and minus plus UB. So what is the final and last conclusion result of the conservation of the momentum is MAUA plus MBUB is equal to MAVA plus MBVB. Sum of the means momentum of initial at both the bodies is equal to the momentum of final position. That is known as conservation of momentum, mathematically proved. Now, second, activity number 9.5 and 9.6, these two activity also. So, in this activity, suppose you take one big rubber balloon and inflate it fully. So, as shown in this figure, right, a rigid support, a tight the strain, and a straw. You passing one thread between this and keep this balloon tight with this. When you know that as the thread tied on the neck of the balloon is removed, when you remove this thread, right, the air from inside of the balloon expects the mouth of the balloon, means this air, correct, this side can be. So what happens when as a reaction the balloon moves in the opposite, so balloon move in the opposite direction. So, what can be concluded from this? Right, the straw moves over the thread along the balloon and balloon in the opposite direction. So, this activity can be also show that the law of momentum or conservation. Now, one more activity number 9.6. What is activity number 9.6? You take one, right, test tube, and suppose this is on stand, test tube filled with water, stand glass test tube, and it is strongly start to heat. This is the cork, hard rubber cork and burner. So as shown in this figure, right, you tight one glass test tube filled with water and tight with cork. When you heat this water, heat supply, water start to evaporate, and then we observe that heat the test tube with burner until the water vaporization and the cork blows. This cork is blown, means it comes out from the neck of the test tube, means blows out outside this. Then what happens? The force is, observe the test tubes recoils in the direction opposite to the direction of the cork, means it is the opposite direction. So opposite direction of the cork recoils. So this activity is also concludes that the cork acceleration in the test tube is much lesser compared to the acceleration of the cork. So today I complete these two activities. Now all of you see example number 9.6, 9.7 and 9.8. These three examples are solved in your test book. You read it, examples, and write down both the activity number 9.5 and 6 in your classwork and complete your classwork of lesson number 9. Next time we can start new lesson.